Mhm. Okay. Okay, so this is statistics review. Okay, I'll be using the material from Dr. Prospero Naval, Department of Computer Science, University of the Philippines. Okay, so statistics review. So when we talk about probabilities, okay, we usually talk about sample spaces and events. Sample space, which is this omega, this symbol, the omega symbol, is a set of possible outcomes of an experiment. Points, small omega, or that small w looking symbol, is an element of the sample space. Then that points, small omega, are the sample outcomes or elements. Some subsets of the sample space events. Subsets, di ba? A is a subset of B if all the elements of A are in B. So, parang yung events ay miniature space or sample space because not everything in the sample space might not be in the events. Okay. So for example, we want to toss a coin twice. R omega is equal to sets HH, HT, TH, TTR, head on the first toss, head on the second toss, head on the first toss, tail on the second toss, tail on the first toss, head, and then tail. So we have 4 possible outcomes. Okay, so one of the event that first toss is heads. So A is head, comma, head, tail. So whatever the second toss, but our first toss is head. So that's the event. The sample space will be all the possible outcomes. Another example, let small omega be outcome of a measurement of some physical quantity. Example is temperature. So our omega or big omega can be the set of real numbers or from negative infinity to positive infinity. But the set of real numbers is not accurate because temperature has a lower bound, but no Harmon sample space is larger than needed. So we can start at 278.15. Am I right? Kelvin to positive infinity. Okay, another example. Event A that measurement is larger than 10 but less than or equal to 23. So this is A equals to open parenthesis 10 um, straight bracket 23 straight bracket 23 including 23. So another example, we want to toss a coin forever. Of course, the question forever may be debatable. Okay, will we reach that idea or time or space? Okay, it's forever, time, or space. Anyway, so this big omega or our event will be omega, small omega, which is equal to small omega 1, small omega 2, small omega I, dot, 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 such that small omega I is an element of H comma T. So for example, if event A, the first head appears on the third toss, so small omega 1 is equal to T. So that will be tail, tail, and then head on the third toss. And then W sub I will be head, tail, such that I is greater than 3. Yun yung event natin. Okay, some operations on the events. So since A is a subset of the sample space event, A is a subset of sample spaces. So there we can use operations on events. So the first one is a complement of event A. So A complement is equal to small omega element of big omega, such that small omega is not an element of A. Complement of A is also called not A, or sometimes A prime, A apostrophe, or A bar. Then the complement of omega is equal to null set. Okay. So parang yung omega natin o yung sample space is the universe, no? Universe ng set natin. So the complement of the universe is null set. Union of events A and B. Union of A, B is equal to small omega element of big omega, such that small omega is element of A, or small omega element of B, or small omega element of both. Think of A and B as A or B. If A1, A2, dot, dot, dot is a sequence of sets, then the union of A sub I from 1 to infinity is equal to small omega element of big omega, such that small omega is element of A sub I for at least one I. Kasi union, di ba? So, pagsasama-sama natin yung mga common nila. Tapos, kung na-separate man sila, okay, pwedeng yung small omega natin element ng A sub I, okay, or A sub J, or A sub I plus 1, and so on, so on. So basta dapat meron sa mga sets na yon dito sa ating unions of A sub I, ito. So merong element, may set or event na element siya, yung ating small omega, for at least one I. Then we have intersection of events A and B. The intersection of A and B is equal to small omega element of big omega, such that small omega is an element of A and small omega is an element of B. Both A and B contains the event, the outcome pala rather. The outcome. So our events are A and B. Okay. Thinking of A intersection B as A and B. The intersection of A and B is also written as AB or A comma B. If A1, A2 is a sequence of sets, then the intersections of A sub I from 1 to infinity is equal to an outcome element of the sample space, such that that outcome is an element of A sub I for all I. Kaya for one of the I's, ngayon for all I. Okay. Questions? So parang ni-review natin yung discrete math nyo, no? Yung topics on sets. But this time, our sets are events. Okay, set difference. Okay, A minus B is equal to omega, such that omega, small omega is an element of A, and small omega is not an element of B. If every element of A is also contained in B, we write A subset of B. If A is a finite set, then the cardinality of A, or the number of elements of A, denotes the number of elements in A. Sample spaces and events pa rin. This time is disjoint or mutually exclusive. Sets A sub 1, A sub 2, dot, dot, dot are disjoint or mutually exclusive if A sub I intersection of A sub A is equal to 0, whenever I is not equal to J. Partition of the sample space or of big omega is a sequence of disjoint sets A sub 1, A sub 2 such that the union of A sub I is equal to the sample space. Okay, so pwedeng A equals to H, kunyari, 2 coin toss yung ating event. Okay, so yung sample space natin again will be HH, HT, TT, TH. So pwedeng A sub 1 is equal to HH, HT, H sub 2 equals to TT, TH, and A sub 3 equals to null set, and then we have a partition of the events or of the sample space rather, or the big omega. Indicator function. Okay, questions? Oh, what's this?
Wala na, sir.
Connecting si Rafi. Okay, sige. We'll just continue the discussion para ma-post na lang natin sa group natin. So I'll post it muna sa YouTube and then post it later sa Canvas. I'll post a link. Okay, so we have now indicator function. So given an event A, the indicator function of A is I sub A of small omega, which is equivalent to I small omega element of A. Is equal to 1 if small omega is an element of A. 0 equals to if omega is not an element of A. Can you give another indicator function? So, pwedeng A is an event, diba? So parang tossing a coin once. So yung omega natin ay head. Kapag head, 1. Kapag tail or kapag not head, 0. Okay, so that's an indicator function of our event A. Okay, probability. Yun, sa probability na tayo. We assign a real number, P of A, to every event A called the probability of A. P is the probability distribution. Definition of probability. It's a function P that assigns a real number, P of A, to each event A. A is a probability distribution if it satisfies the following actions. Probability of A is greater than equal to 0 for every A. So there's no negative number, no? For our A. The probability of our sample space equals to 1. If A sub 1, A sub 2 are disjoint, then the probability of A sub i's or of all the events which are disjoint, and this is equal to the summation from 1 to infinity of P of A sub I. So when we have a disjoint, mutual, natakal natin mutually exclusive, no? So if we have a mutually exclusive events and the total, okay, and the total is equal to 1, then all of the possible events are represented, no? Or disjoint events are, which can represent all the events in our omega or sample space. Kung equal sa 1 yun, so yun sila. Kung disjoints, isasama lang natin yung mga yung mga probability ng A sub I. Kunyari, disjoint. So kunyari, tossing a coin and we get a head, or tossing a coin you get a tail. So your A sub I will be getting a head on the toss, getting a tail on the toss. The probability of getting a head will be 1/2. Probability of getting a tail is 1/2. So 1/2 plus 1/2 equals to 1. So actually A sub 1 natin na head, getting a head, or getting a tail, A sub 2 natin. So disjoint sila at yung total nun, sum ng probability na yon, total natin 1/2 plus 1/2 is equal to 1. So parang represented na yung sample, yung outcome sa ating sample space natin kasi equals to 1. Kasi nga the sum of the sample space, the probability of the sample space is equal to 1. Interpretations of P of A. Frequencies. Proportion of times that A is true in repetitions. Ito pala, probability of heads in coin toss equals 1/2 when repeated an infinite number of times. An idealization similar to the concept of line in geometry. Okay. So a line is on a plane. Okay, so one line would represent one out of all the possible lines in a plane. So 1 over infinity, something like that. Okay, anyway, that would be 0 naman. 1 over infinity is 0. Okay, degree of belief. Excuse. PA measures an observer's strength of belief that A is true. Difference in interpretation will not matter much until we deal with statistical inference. For both interpretations, the 3 axioms must hold. Okay, so some properties of P derivable from the axiom. The probability of the null set is equal to 0. How did we get that? Kasi no event, diba? No outcome. So 0 outcome over all the possible outcome is 0, diba? So yun. Next is A is a subset of B implies the probability of A is less than or equal to the probability of B. Anyone who wants to prove? Tawag tayo. Ay, naka-record to so don't be shy. We'll just sabagay sa baka privacy issue na. Sabihin, bakit po nakikita kami dito? Sige, dapat pala magpa-sign on ng waiver. Privacy waiver. You are allowing to publish the recorded lecture for the usage of other classmates. Siguro. Anyway, next axiom, or axioms are defined truth, okay? Or you just want derived truths naman to. Okay, 0 is less than equal to probability of A less than equal to 1. The probability, next, the probability of the complement of A is equal to 1 minus probability of A. And then, if the intersection of A and B equals to null, then the probability of A union B is equal to the probability of A plus the probability of B. Well, you can use some of the axioms later, and as you move on with probabilities, so you can discuss, you can use the axioms that we have. This one are derivable from the 3 axioms or 3 definitions, no? Yun ang una. Okay. Okay. Lemma. Okay. Lemma means a proof before a proof. Okay. So before. Corollary is after, no? So lemma is before a proof. So we want to prove for any events A and B, the union and the intersection of A and B is equal to the probability of A. So the probability of the union of A and B is equal to probability of A plus probability of B minus probability of AB. So some proof, the union of AB is equals to A intersection with complement of B, and then AB, and then A complement of A intersection with B. And note that the events are disjoint. Use repeatedly the fact that P is additive for disjoint events. The union of AB is equal to P, AB complement of B, AB, A complement B, and then AB complement is equal to PAB plus PA complement B plus PAB minus PAB. How did we get that? Okay, so ito yung probability of AB. Okay na yan. Ito, we just added this, no? Parang out of the blue. Ano ba tawag nila yan? Monster ba yan? Hindi naman, ano lang, ano tawag nila dyan? Multo pala, multo. May dinagdag lang tayo. PAB minus PAB. And then we regroup the expression. So we now have probability of A plus probability of B minus probability of AB. So yun, AB complement, union of AB, A complement of B, union of AB. So this is PB. This one is probability of A. Okay. Questions? Okay, so far, ano pa? Nakasunod pa tayo. Questions?
None, sir.
Yes?
Wala
Wait
po,
lang,
sir.
Okay, wait lang. How do we see? Limiting controls. Okay. So, may pause share tayo. Sino yung may tanong? Okay pa, Andrew, Hanilin, Ken?
Okay po, sir.
Wala
Sige.
pong tanong.
Okay. Or Sean. Okay, excuse na.
Okay na rin, boss.
Okay, ito naman. Sige. Let's continue. Okay, are we ever done with this? Okay, example. So let's apply what we have learned. 2 coin tosses. Let's H1 be the event that head occurs on toss 1, and let H2 be the event that head occurs on toss 2. If all outcomes are equally likely, then the probability of H1 union H2 is equal to probability of H1 plus probability of H2 minus probability of the intersection of H1 and H2. Head 1, or on the event that head occurs on toss 1, so ilan yan? Head, tail. So 2/4 for the possible, possible outcomes. So 1/2. Head 2 is, let's HT be the event that head occurs on toss 2. Tail, head. Okay, so 2/4 or 1/2 pa rin. Probability H1 and H2 occur, so the intersection nun, so H1 head occurs on toss 1 and head occurs on test 2, so HH. So isa lang siya over 4. So 1/2 plus 1/2 minus 1/4 equals 2, 3/4. So the probability of the event head occurs on toss 1 and the event that head occurs on toss 2 is equal to 3/4. Okay ba yan? Okay, excuse lang. Okay, excuse. Okay. Question? Okay. So probability on samples, on finite sample spaces. Suppose that the sample space omega is equal to the set containing small omega 1, small omega 2, small omega n is finite, and the outcome is equally likely, then the probability of an event A is equal to the cardinality of A over the cardinality of sample space, where the cardinality of A, or 2 bar, may dalawang bar sa A, denotes the number of elements in A. This is called the uniform probability distribution. So example, toss a die twice. If each outcome is equally likely, then the probability of A is equal to the probability the cardinality of A over 36. Okay. Probability that sum of die is 11 is 2/36, since there are two outcomes that corresponds to this event, namely 5/6, 5 on the first toss, 6 on the second toss, 6 on the first toss, 5 on the second toss. So okay, so since sum nila is 11, so 2/36. Okay ba yan? Okay. Some concept on finite sample spaces. To compute probabilities, we need to count the number of points in an event A. Okay. Given n objects, the number of ordering this object is n factorial equals to n minus 1, n minus 2, 3, 2, 1. So parang kung may 13 na cards tayo, A to K, so ordering yung objects natin would be n factorial. So 13 factorial. Una is 1. So may 13. Then 12. Then 11, 10, 9, 1. We define 0 factorial equals to 1. The number of distinct ways of choosing k objects from n is n taken k, which is equal to n factorial over n minus k factorial times k factorial. Note that n taken 0 is equal to n taken n, which is equal to 1, and n taken k is equal to n taken n minus k. Okay, we have a class of 20 people and want to select a committee of 3 students. There are 20 taken 3, which is equal to 20 factorial over 3 factorial 17 factorial, which is equal to 20, 19, 18. Tapos tanggalin, cancel yung 3 and 2. So 3 na lang. So 20 times 19. Yan ba yan? 380 times 3. So it's 1140. Okay. Questions? Okay, sige. So since this is my parang somewhat panata to din, I would post some problems sa Canva siguro para matest natin kung meron kayong naintindihan. So I would put the video, tapos the video will be studied by your classmates para to check kung meron naintindihan on this. Okay, some definitions. Independent events. Two events A and B are independent if the probability of A, B, or the probability of the intersection A, B is equal to probability of A times probability of B. And we write A pi B as A sets of events A sub I such that I is an element of big I or capital I is independent if the probability of the intersection of A sub i's I element of J is equal to the product, no? Kung summation is sum, ito product. Yung big pi. For I element of J, probability of A sub I. For every finite subset J of I. Independence can arise in two ways. By assumption, we explicitly assume that two events are independent. Example, toss a coin twice. Assume that toss are independent since coin has no memory of the first toss. by derivation, derive independence by verifying that PAB is equal to P of A, PB. So we toss a fair die. Die. Yung, ano sa Tagalog, die? Ano ang sa Tagalog? Die, yung may 6 na sides, di ba? Let A equals to 2, 4, 6, B equals to 1, 2, 3, 4, then the intersection is 2, 4. PAB equals to 2 over 6, which is equal to 3 over 6 times 4 over 6. So it satisfies the okay, therefore A and B are independent. Tossing a fair die twice. Okay, with the values 2, 4, 6 and 1, 2, 3, 4. So A and B are independent. Okay, if all the possible partitioning would be and gives rise to some computation na P of AB is not equal to PAB, then tossing a pair die would not be independent, di ba? Yun lang naman yung negation natin sa ating. Okay. Okay, so A and B are independent. Okay, additional definition on it, additional concepts on independent events. Suppose that A and B are disjoint events, each with positive probability. Can they be independent? No, because PA times PB is greater than 0. Yet the probability of AB, probability of null set is equal to 0. Disjoint events cannot be independent. Okay? So basically, yun yung ating idea doon. Okay. So we toss a fair coin 10 times. Let A equals at least one head, then let TJ be the event that tails occur on the J toss. Then probability of A, at least one head, is equal to 1 minus probability of complement of A. So ano ba yung, kung at least one head, all tails siya. Yun yung complement ng A natin. So complement ng all tails is the probability ng all tails is equal to 1 minus PT1 T2 dot T10, or 1 minus PT1 PT2 dot PT10, which is equal to 1 minus 1/2 raised to 10, which is approximately equal to 0.999. Questions? Okay. Wait lang I'll just pause and pause the recording. Wait, where's that? Recording. Independent events. Continuation. Two persons take turns trying to sink a basketball into a net. Person 1 succeeds with probability 1 over 3, while person 2 succeeds with probability 1 over 4. What is the probability that person 1 succeeds before person 2? Let E denote the event of interest. Let A sub J be the event that the first success is for person 1 and that occurs on trial J. Note that A sub 1, A sub 2 are disjoint and that E is equal to the union of A sub J from 1 to infinity. Hence, P sub E equals to P summation of P sub A J. P sub A sub 1 is 1 over T. A T occurs if we have the sequence person 1 misses, person 2 misses. Person 1 misses. A sub 2 occurs if we have second person 1 misses, person 2 misses, person 1 succeeds. So P sub A sub 2 equals to 2 over 3, 3 over 4, 1 over 3. Which is equal to 1/2 times 1. Following this logic, you see that P sub A sub J equals to 1/2 raised to J minus 1 times 1 over 3. Hence, probability of E is equal to 1 over 3 times 1/2 times J minus 1 from 1 to infinity, which is equal to 1 over 3. And then summation of 1/2 of J minus 1 from 1 to infinity is equal to 2. We use the fact that if 0 is less than R, less than 1, then j equals to 1 to infinity is r sub j equals to r raised to j over 1 minus r. So 2 raised to 1 from 1 to infinity. Yung r natin is 1/2, di ba? So 1/2 raised to infinity over 1 minus 1/2. Okay. Okay. J equals to 1 pala. Summation nun. So yung r natin is 1/2. 1/2 raised to 1 is 1/2 over 1 minus 1/2. So 1/2 minus 1/2 is 1/2. So 1/2 ay raised to infinity na lang natin. So r raised to infinity, 1/2 raised to infinity is 1/2 raised to infinity is 0, 1. So 1, no? 1 over 1 minus 1/2 is 1/2. So 2. So this one, the summation of 1/2 raised to j minus 1 is equal to 2. So 2 times 1 over 3 is 2 over 3. Okay ba yun? Okay. Okay, independent events. Summary of independence. A and B are independent if and only if P of AB, or the probability of A and B, or the intersection of A and B, is equal to probability of A times probability of B. Its dependence is sometimes assumed and sometimes derived. Okay. Disjoint events with positive probabilities are not independent. Conditional probability. Okay. Definition of conditional probability. If probability of B is greater than 0, then the conditional probability of A given B is probability of A given B is equal to probability of AB over probability of B. Thinking of P over AB as a fraction of time, A occurs among those in which B occurs. For any fixed B such that probability of B is greater than 0, then the probability of that over B is a probability. Probability of A given B is greater than equal to 0. Probability of sample space over event B is equal to 1. If A sub I, A sub 1, A sub 2, dot are disjoint, then the probability of the union of A sub I given B is equal to the summation of probability of P of A sub I over B. Okay, let's try to apply it. Okay, before that, in general, it is not true that the probability of A given the union of B, C is equal to probability of A given B plus probability of A given C. Rules apply to events on the left of the bar. Also not true that probability of A given B is equal to probability of B given A. Right. Probability of spots given that you have measles is 1. But the probability that you have measles given that you have spot is not 1. Often made in legal cases is sometimes called the presenter's fallacy. Okay, conditional probability. A medical test for disease D has outcomes plus and minus. The probabilities are outcomes plus is 0.00D, that you have a disease, that you do not have a disease, and that you have outcomes plus is 0.099. Probability that you have a disease and that you have the outcome minus is 0.001. You do not have a disease and probability of minus is 0.891. From definition of conditional probability, probability that you have the outcome given that you have a disease, is probability of plus intersection with D over probability of D. So which is equal to 0.009 over 0.009 plus 0.07 equals to 0.9. And probability of minus, given that you don't have a disease, is minus intersection DC over complement of D, which is equal to 0.891 over 0.891 plus 0.99. It's equal to 0.9. So suppose you go for a test and get positive, what's the probability that you have the disease? So most people will answer 0.9. You go for a test and get a positive. What is the probability that? So given that you have a disease, given and gets a positive. So this is given that you're positive. So it's actually 0.009 over 0.009 plus 0.99. So we have the probability of your positive intersection with you have a disease. So this is 0.009. And probability of plus is 0.009 plus 0.099. So equals to 0.08. So don't trust your intuition. You need to compute it. Okay ba yan? Excuse me. Okay, lemma. If A and B are independent events, that P, the probability of A given B is equal to probability of A. Also, for any pair of events A and B, probability AB is equal to probability of A given B, probability of B is equal to probability of B given A, probability of A. Another interpretation of independence. Knowing B does not change the probability of A. So draw two cards from a deck without replacement. Let be the event that the second draw is the queen of diamonds. So probability of A natin, so 1 over 52. Kasi we draw two cards from a deck without replacement. So probability of A natin would be 1 over 52. Any cards na madraw natin, 1 over 52. And let be the event that the second draw is queen of diamonds is 1 over 51. Kasi may nakuha tayo ng isa. So 52 minus 1 is 51. So 1 over 51. So the probability that we get, we draw two cards from a deck without replacement, and let be the event that the second draw is the queen of diamonds, equal to 1 over 52 times 1 over 51. Okay? Summary of conditional probability. If P of B is greater than 0, then P greater than AB is equal to P AB intersection of AB over probability of B. If probability of that given B satisfies the action of probability for fixed B in general, P probability of A given that does not satisfy the action of probability for fixed A. Okay. General, probability of A given B is not equal to probability of B given A. A and B are independent if and only if the probability of A, B is equal to P of A. Okay, can someone derive this one? If A and B are independent, if and only if probability of AB is equal to probability of A. Okay, so you might want to try that. I might give that sa canvas natin. So that gagawa ko ng ano. And then these are the base theorems. So we limit our discussion here. We end here. But this one is the law of total probability. Base theorem. Yung probabilities of ano. You can study this later. Okay. Okay, parang generalize lang natin yung base yung conditional probability. So yung B natin compare yung partition natin compared with B. Okay? So such that P sub A sub I is greater than 0 for each I. If P sub is greater than 0, then for each one each I equals to 1 to k is probability of A sub I given B is probability of B given A sub I times probability of A sub I over the summation of probability of B given A sub I times probability of A sub J pala, sorry. Summation of J's. So P sub A sub I is the prior probability of A sub I given B is posterior probability of A. So we apply the definition of conditional probability twice, followed by the law of total probability. Okay. So for example, I divide my email into 3 categories. A sub 1 equals to spam, A sub 2 low priority, A sub 3 high priority. From previous experience, I find that A sub I equals to 0.7, that the mail would be spam or low priority. A sub 3 high priority is 0.1. Let be the event that contains the word free. From previous example, P of B sub A sub I equals to 0.9. P of B sub 8 is 0.01. P of B of sub 8 equals to 0.1. Note that 0.9 plus 0.01 plus 0.01 is not equal to 1. The answer, the probability of A sub 1 given B that the email contains is spam, and that the email contains the word, given that the email contains the word free. Okay, ganun yun, di ba? Okay, and that's the computation. Questions? Sige, gawa pa ako ng gawa na lang ako ng exam nyo mamaya. For next Friday nyo na lang exam yun, or sometime between today and Friday. Basta I'll post it bago mag-Friday. Okay, summary. Probability of multiple events. Addition rule for non-mutually exclusive events. For two non-mutually exclusive events, A and B, A or B is equal to probability of A plus probability of B minus the probability of A and B. Addition rule for mutually exclusive events. For two mutually events, A and B, the probability of A and B is equal to probability of A plus probability of B. Multiplication rule for dependent events. Two events A and B are dependent if the occurrence of one is in some way connected to the occurrence of the other. So parang yung drawing of cards without replacement. Diba? Kasi pag natanggal na yung isa, mababawasan yung mga previous. I mean, may mababawas na isa, diba? Kapag nag-draw ka na ng isang card, may mababawas na iba. Parang ganun, diba? Two events A and B are dependent if the occurrence of one is some way connected to the occurrence of the other. The joint probability of A and B is probability of A and B is equal to probability of A times the probability of B given A. Multiplication rule for independent events. Two events A and B are independent if the occurrence of A is not connected in any way to the occurrence of B. Example, probability of B given A equals probability of B. So the probability of A and B equals probability of A times probability of B. Ito na pala ang kailangan natin pag-usapan. Random variable. Okay, stretch pa tayo. So it's a mapping, no? So from the sample space to real numbers. Kunyari, head equals to 1, head tail equals to 2, tail head equals to 3, tail equals to 4, pwedeng ganun. So that assigns a real number x over xw or small omega to each outcome small omega. So we flip a coin 10 times. Let x equals to small omega. The number of heads in the sequence small omega. Small omega is head, T, head, T, head, T, tail. Then x sub w equals to 6. Okay ba yan? Okay, another example. Let omega is equals to x comma y such that x plus y squared is less than equal to 1, the unit disk. We draw a random x sub y from omega. So the random variable is x omega, x of small omega is equal to small x, y of small omega is equal to y, w of small omega is equal to square root of x squared plus y squared. Okay. X, the big X will be the x's, y will be the y's, and the squared x squared plus y squared would be, what's that? It's the distance from the center, no? Or the area of the disk in W natin. Okay ba yun? So given a random variable x and a subset A of the real line, the probability of x element of A equals to probability of small omega element of sample space such that x of W is an element of A. P of x equals to x is equivalent to P of small omega element of big omega such that x of small omega is equal to x. Okay. Flip coin twice. Let x be the number of head, then P of, P of x equals to 0 equals to P of tail equals to 1 over 4. P of x equals to 1 equals to head tail head, which is equal to 1/2. Px equals to 2 equals to P head equals to 1 over 4. And you have the table there. Okay ba yun? Okay. Okay, may question pa kayo? So the cumulative distribution function. So flip coin twice, let x be the number of heads. Px equals 0 equals 1/4, x equals to 1/2, x equals to 2, 1/4. So from 1 to 0.25, ito yung from 0 to 1, and 1 is not included, is 1/4. Then 1/4 plus 1/2 is 0.75. So from 1 to 2 is 0.75. So we just add the 1/4 and 1/2. So 3/4. And then plus another 1/4, we have 1. We just exclude the x, no? For example, this one we exclude from 1 to 2 lang siya, 2 excluded. Yung una is from 0 to 1, excluded yung 1. 1 to 2 excluded yung 2, and so on. Then we just add the probabilities. CDF is right continuous if non-decreasing. CDF is defined for all x two random variables takes discrete variables. Though random variable takes discrete variable. It's for all x, defined for all x random variable that takes discrete values. Okay, this one, we'll have this on later on na lang. Kapag we need to compute the CDF. Okay, may question pa kayo? At least we have an introduction of random variable. So we will be using random variable. Question ta? Meron pa kayong tanong, guys? Wala naman na. Sige. So kung wala kang tanong, I'll just post the quiz later. Gawa pa ako ng quiz para to check if you have learned something or naman. Or kung may question pa kayo or wala. So yun. Okay, stop the recording. Thank you for joining this morning, this class, this session this morning.